Hello everyone, my name is Kirill. I'm a Python software engineer at Picnic. If you have never heard about us or haven't seen us yet, we are actually present at this conference. So feel free to come at our corner to say hi, or if you're joining this talk online, also find some information on Discord or our website. We're actually doing quite some cool stuff. And I will share the link at the end of my talk, which actually will be called Breaking HTTP Boundaries, ASGI to build a fleet management system in Python. So today we're going to speak quite a lot about web server development and specifically about ASGI, which is mostly primarily known for building HTTP web servers in Python. But I would love to make a point that it's not limited to HTTP. And we will play with it a bit and maybe have a closer look to the core ASGI concepts and look at the supported protocol specifications. And as I said at the end, maybe to try reflect a bit more and see how we can actually reapply it for something out of the standard spec. And I will try to do it step by step, a bit more interactive. So I believe I will try to provide some practical insights for your own project. So let's start. I think the first most important point here is to make what actually ASGI stands for. So the abbreviation stands for Asynchronous Server Gateway Interface. And it's basically a communication standard around which to build web servers in Python. If you've never heard about ASGI before this talk or never checked the spec, you probably have heard of tools like Fast API, Starlet, UVcorn, Hypercore, and many, many more, which all are ASGI compatible. And maybe to make a bit more clear what actually ASGI solves there and provides us, let's try to build a simple HTTP web server from scratch. So let's say we want to build an echo server. And sounds like a pretty easy task. So let's just write a Python function that receives one parameter and returns it back. Seems like we're done with all our business logic. Backend is ready. However, I think we actually haven't completed the task yet. So we have to do quite some work still, meaning that we still need to handle the all low-level network connections, basically handle the transport and terminate the sockets and know how to do it. And as well, we actually need to translate raw HTTP bytes that our application receives. And we need to know the HTTP spec by heart or check the doc. So it's quite a lot of work to do. And even if I managed to make it working, maybe my colleague did it in the other way, and we'll have a lot of argument how to actually do it correctly, and maybe some other have a different way of doing it. So it's still, there is quite some room for improvement, and what actually ASGI is trying to solve for us. And if we look at the web server, maybe from a top-level perspective and try to understand what does it do, we can identify some pattern here. So we have quite common server logic, which is related to transport level thing and the protocol handling, as I mentioned before. And we have server-specific logic, which is basically a core idea of our backend, what we actually want to have in our application. And ASGI sort of tries to solve this by introducing the idea, let's split this in two separate Python components, and one will be responsible for one part, which is a bit low level, related to presentation level, and the other one, which will be more application level thing. And ASGI introduces these two ideas of having a protocol server, one part of our web server, and the other is application, which is core logic. And ASGI as interface plays as a bridge between them, basically allowing them to communicate. So we have quite some benefits here. First of all, the logic is quite nicely isolated and grouped already, so we do not mess our code around the places and avoid unnecessary coupling. Secondly, as you might understand, if I need to build a second web server, I don't need to re-implement protocol server. I can create it only once. Or if we flip this other way around, I can be just an application developer, which is quite common nowadays when we use Fast API framework, for example. So we don't deal with this HTTP standard directly. So we basically use high-level abstractions. And sort of it looks quite a bit like this. We use our application and we plug it into protocol server, and then everything magically works for us. Yeah, and that's super nice. ASGI solves quite a lot of problems here, and we can already benefit quite a lot, but is ASGI the first one to introduce this nice idea? Well, actually not. I think the concept is sort of existed for quite a long time before, and I guess it's also quite natural to also other languages, so it's not really specific to Python. So let them, yeah, maybe even see how it was done there before. So if we look at the Python web server standards evolution, we can actually see that the same idea, well, maybe first appears even in 1993 with a CGI standard, and then later evolved into WSGI, WSGI standard, like web server gateway interface, resulting in a PEP 333, and reworked a bit with the next version, and only after we have ASGI as we know it nowadays. So what then ASGI is for, why it was invented, and what actually it solves for us, why it's better than its predecessors. For this, we actually need to look closer at details, how the contract between protocol server and app is implemented. Because as it often happens, the devil is indeed hidden in the details. So let's have a closer look, and I will make a small break here. So if we compare WSGI standard to the closest predecessor of ASGI, we can actually notice that the application definition sort of changed a bit. In WSGI, the application was represented as a single sync callable, maybe in the easiest form, like just a function with two parameters, env and start response. And since ASGI was invented, introduced some changes. So we changed our definition to a single async callable, receiving three new parameters: scope, receive, and send. And let's maybe try to understand better what effect it had on example of a simple HTTP request. So we have a request demonstrated here for WSGI. So whenever our protocol server receives data from a client, it does some processing, basically sort of converting incoming bytes to like objects that it can work with, and then it invokes our application by calling it, specifying two parameters, env, which is a dictionary that contains all the data about our request. So let's say method and the parameters, the URL, all this is available in this dictionary. And as well, it provides one callable start response, which our application can use sort of to call back the protocol server with a status code of the handling and the headers. And then when our applications can, well, basically returns an iterable of bytes, which is represents the body of the response, which our protocol server can iterate over and send the response back. So looks quite clear, but we can already notice that it's quite coupled to HTTP protocol. So first of all, the flow is hard-coded here, and also the method definitions. For example, start response also assumes a status code to be provided. So we can actually see that WSGI itself is not, well, meant for something else than HTTP protocol, and do not support any other protocol flows. So this was one of the main motivators, what sort of make us think about, can we do better? Can we try to make it more flexible, more generic? And this, it introduced ASGI. And since, well, we have ASGI, we can actually look at the diagram, and it looks quite similar to what we had before, but the mechanism of sort of interaction between protocol server and application changed quite a bit. So first of all, our protocol server now do not call application, let's say, directly, but it emits event whenever it has a client data. So, well, of course, we sort of call our application, but our app itself retrieves the events using the receive pipeline, a sync callable that we have in our method declaration, as well as our protocol server can receive the data from application. Whenever it's ready, it can use a send callable to provide us some data there. And this makes this interaction a bit more flexible and generic, because now they act in their own pace, fully decoupled, and are basically exchanging events with each other, meaning that we sort of have already exceed this HTTP hard-coded flow, and we can support other protocols like a WebSocket, which becomes available in ASGI sort of with a more clear and then, well, native syntax here. So now we can exchange event from protocol server and application quite easily. And this sort of feature also propagates to our client, so our client can receive data from protocol server also at any time, basically making a WebSocket available. So this summarizes which nice benefits ASGI provides us. First of all, it naturally brings all this async syntax to WebSocket or web server development in Python and unlocks all the concurrency benefits, which are important, but maybe for this talk specifically, what is more important that it allows us to have more like flexible flows for protocols we can support. So we basically enable kind of full duplex protocols where, well, they can act in a full duplex mode, basically detached from each other and exchanging events at any point. Great. So these are the two main benefits I can see from the ASGI rationale and redesign. And since we can support more protocols and not limited to HTTP, we can actually start thinking what are supported in ASGI by default. And by default, we have 3 protocols, HTTP and WebSocket that I have already mentioned before, and the lifespan protocol, which I find quite important and interesting also to discuss here. Because lifespan protocol has nothing to do with the client-side data. It's still a protocol that exists between our protocol server and application, and also uses the same pipeline of events. We basically exchange them using the receive and send callables, async callables. But this protocol is more about how to sync the states between these two on a startup and, let's say, shutdown. And it also proves how generic actually ASGI protocol becomes. So let's see this event flow on the example of HTTP request. So here our protocol server receives some data from a client, and then it emits the first request, the first event to, well, application, basically specifying the type, HTTP request, which our application can use to understand what will be the structure of this event, because it's all in ASGI specification. So it can rely on the format, expecting method, pass, and other parameters as well. And same way our protocol server can treat application events. So whenever our application is ready, it can emit the first event, HTTP response start, specifying also the expected structure. So we can actually see how these two are aligned and how these events are modifying the behavior of each other. So for example, whenever our application starts returning the request response, we emit an event HTTP response body, but we can also specify a parameter more body true that will let our server understand that we should expect, well, at least one more event with this kind of type. And yeah, this sort of nicely synchronizes the way how these two work together, and summarizes all the 3 possible events for the HTTP flow. And what ASGI specification do as well is define this events and their types with a structure within its own spec. So we can see that there is 6 events defined for a WebSocket, and also 6 events defined for lifespan, and there is also some events for disconnection that I haven't placed here. But in a nutshell, ASGI sets of standard message formats for each of these protocols. So I find it really nice about ASGI design, and I was really loving it for quite some time, and then I decided to play around it because, I actually see that we can support not only these protocols, and I was about to challenge how flexible ASGI can be, and I decided to try to support something out of the standard spec. It can be, well, any protocol of your choice, and I come with this simple idea. So yeah, the world is not limited to just HTTP and WebSocket protocols. And if we look at the automotive industry, for example, so the vehicles that, well, used to try send some data to the servers, for example, you want to analyze the sensors that the vehicle has and their location, and sort of try to build a fleet management system. They use sometimes vendor protocols that are more related to the hardware they have for this interaction. And these protocols, well, sometimes they have open spec, like this one I found online called Teltonika, which basically describes how the message of Teltonika, what frames are available and how the vehicle should interact with the server. So I decided how hard it can be to support this protocol. This was just a sort of a pure interest that I like to play with a bit. And I set this simple idea. So let's say we have a vehicle that sends us telemetry data. I will try to build a web server fully powered by, let's say, ASGI design and all this flow. So I'll try to implement a protocol server and an application to provide a nice UX sort of. Whenever you build a web server for HTTP, you have this high-level abstractions, and I want to achieve it also for other protocols that are not HTTP. And at the same time, nice idea was let's expose a small UI interface for users so they have a live stream seeing how a car performs on the map, maybe showing some logs and the sensors, and I end up with this small idea. So first of all, my idea was to indeed build a map where you can track the car in real time. So here you can see a car traveling around Prague. And the second idea, I decided to deliver a very nice developer experience. So you have indeed all the low-level abstractions of the protocol fully somewhere else. So you just, as an end implementer of final application, only care about the high-level structures, so login or data, and you can basically create it as you do for Fast API. So I decided to do this experiment, and I identified some steps I need to do that I would love to share with you today and show you what you can actually try to achieve when you implement the support for your own protocol, because of course we're not limited to this Teltonika one. You can actually reapply this idea for something else. So first of all, we need to build a protocol server which will contain two key elements, is a Python server itself and a protocol library for parsing the protocol. We also need to build an application, but as I said before, would be nice to create a very high-level API, so we'd love to have some small layer of a framework that we can use as well, and our instance that we create, our application can be just instance of this framework, we'll have a very short implementation at the end. And to make them sort of glue together, we actually need to identify the event specification. So how protocol server can tell application what to do and what events are possible for this protocol. And of course, we need some sort of small client emulator to test all this. So let's walk through all of them, and I will try to share what I found interesting and maybe give you some suggestions or ideas or insights. So first of all is a protocol server. So to implement just a server that can accept connections. So this protocol is a TCP-based protocol, same for as HTTP. So for me, it was suitable to use async-IO server. And what I actually find nice here, and this will be like a first tip, is to use async-IO.protocol part of the async-IO library, because it's exactly meant for creating your own sort of wrappers around protocols. So whenever we have a new connection, we create a one-to-one instance, like an instance of Teltonika protocol that will have access to the transport layer, so we can actually send and receive data. And this is a callback-based API. So whenever some data is received, actually our method data received with the parameter data is called. Nice. And actually, it is implemented the same way for Unicorn that you might have heard before implementing your HTTP web server. So if you look at the source code, you can actually see quite similar approach implementing the WebSocket protocol support and let's say support for HTTP protocol of version 1.1. Good. So now we receive the telemetry data. We have access to raw data, but we still need to sort of extract the frames and understand what our vehicle sent to us. And for this, we need to implement a protocol library, which will actually do quite more work than we can imagine at the beginning, because it's not only about parsing the incoming events, but it's also for tracking the state and the way how we respect the protocol rules. So on the right, we can see a small diagram that shows the happy flow. So the first vehicle should send us a login packet, and if login was accepted, then we can expect a data packet to arrive. And for this, we can say that if the data packet comes before login, it is actually invalid way of interacting with our server. So we need to create a class that can also keep internal state, and we can implement it like this. So we have some internal buffering, and we have a state which we can use to identify at which point of communication we are now. And we expose a method next event, which our users of this protocol library can call to extract events from the, let's say, our buffer. This works pretty well, and I see a very important point here to mention that this class has nothing to do with I/O. So it is fully abstracted from the way how we receive this data. And this is a very important point because you can use this sort of approach everywhere outside your web server. It doesn't need to do anything with it. And the second thing, which I also find quite important here to mention, if you adopt the same approach for your own protocols, or you want to rewrite, let's say, HTTP library, whatever, here we don't do a complete parsing. For us, what's more important here is to extract frames from the incoming PyThe stream. So we do like a sort of partial parsing just to retrieve the frame, but we don't jump into the message itself, trying to decode, let's say, the latitude, the longitude, and the all sensor values. So we'll leave it for later for the framework or application. But you can decide based on your protocol needs here. And since it's implemented, I would like to say that I was really inspired by the Hyper project doing this, because in the Hyper library, which is actually implements this for HTTP protocol of version 1 and 2, and this library is used by, let's say, Hypercorn web server, they do quite the same thing. So you can also see how the events are retrieved, and they also sort of just the frames that represent the HTTP incoming messages. So I also attached a link here, so yeah, you can find the README and see the rationale and maybe a bit more inspired how to sort of build a proper vision on top, what's the core idea of this. And yeah, our protocol server is almost complete at this point. The last thing we need to understand how to wrap the frame to the ASGI event. For this, we need to build an event specification. So you have to carefully read what protocol you want to support and understand the flow. So here on the right, I have a small representation of this protocol. So first of all, we receive a login event. We receive a login, and then our protocol server will emit a tiltonica.login event type to our application, and our application can decide whether it's a valid login or not and respond to protocol server with reject or accept. And the same way for data, whenever we got an event with data, our application can decide whether it needs to reject or accept it. So yeah, it summarizes to this 6 possible events, and also you need to identify the structure of each of the events. Okay, so protocol server, almost complete. Last thing to do is to start the ASGI pipeline handling. And you can start it in multiple ways. So here I just started in the same event loop. So you create a scope, you specify the type. So here I use Teltonica, but for HTTP, for example, the scope will be HTTP, as you can guess. You also need to define these callables, this async callable, send and receive. For example, my receive callable will be returning the application, the login packets and the data packets, and the send, I will actually implement the side for the protocol server when we receive some events from application, what we actually need to do here. And we start our application by running self-app and providing these 3 parameters, scope, receive, and send. So you must already notice that our application sort of confines to the standard we discussed before for ASGI. Good. So we should move on and start implementing our application. Here, as I promised, we need to build a small framework. And I really decided to keep it super small and simple, basically doing 2 things. We have an API to register handlers. For example, here I have a small decorator login that allows you to just create a function that you can attach to a login handler. And whenever our application is called, it acts as a dispatcher. So an appropriate handler is invoked, and we process to sort of handling the incoming event. This is very, very small. Of course, you can expect way more features in your framework. But to give you some, again, external link or inspiration, if you look at the Starlet framework that is also used by Fast API internally, you can notice that they do sort of same thing whenever they try to match the route of your HTTP request. So we iterate over route, we check which one we actually need to use to handle the request, and we execute route.handle, basically propagating the scope, receive, and send. And maybe what's also important to note here, you can see that our application function is ASGI compatible, so it's like an ASGI function. It has scope, receive, send parameters, it's async. And we can also see that route.handle is also ASGI compatible application. So we can see how we sort of nest this ASGI apps and ASGI apps, and we can layer them so we achieve a pretty nice way of building abstractions, and the end APIs that our user will have will be quite short and very direct to what we want to achieve, just high-level APIs. Good, so dispatcher in place. Finally, we need to build our application to handle the data, and at this point it's super simple. We just init our ASGI application instance, we register 2 handlers for login and for data, so basically reject all the logins that we don't know, and for data, put the records that we receive in a queue, and update the vehicle object with the current actuals of the latitude and longitude, and return the sort of acceptance message, acknowledgement. Good. I promised to do one more last thing to build a UI for this Python application. And here, what I actually find super nice to use is a nice guy library, which is a way to build a UI in Python, also sort of with ASGI approach. So this library is also built on top of Fast API. And here, to create a UI page, I have nothing else to do, but rather than defining a function that will create my view with elements, logs, and create a leaflet map with the markers that will represent my car, and set one background task that will update the location automatically, and all the rest is done magically by this framework. And if we put all these things together, we can actually achieve a fully working application, a small fleet management system that shows live logs in real time, and also show how the car moves, well, in this case, around Prague. And what I want to make a statement here is that all this was sort of powered by ASGI. So the view is built by HTTP servers served by ASGI. The live logs and all the data we received by car was also developed with an approach of, well, sort of ASGI ID and implementation, and sort of I just support a new protocol in ASGI. And lastly, all the sort of live updates are only possible because we have a WebSocket connection here where the sort of update events arrive to our HTTP page. So it's also powered by ASGI. So we have here a pure example how ASGI is used beyond the HTTP scope, which I find quite nice. And well, if you ever wanted to contribute to ASGI and see other opportunities, you can definitely do so. And I just want to share at the end the links to this project so you can explore and maybe grab some inspiration from it. It's very, very small, just for the demo purposes. As I said before, I have a link to our company, Picnic Technologies. We're actually actively hiring, so please have a look. And if you want to stay in touch, here's my LinkedIn profile. And thank you very much for joining, and have a good lunch.